Hello, friends. This will be the first video you're seeing. So in case you don't know, I'm Ben Marlin, and this is calculus. Since this is one of our first videos, I would like to get a little feedback from y'all about some stuff. One thing is, how is the resolution? How is the bandwidth? Are you getting buffering going on? Because if so, I might be able to do something with YouTube instead of directly through Zoom. Let me know about that. Insofar as resolution, let me know whether you'll be able to read the stuff that I put on screen and whether you can appreciate my rugged good looks. So, yeah. In any case, I'm going to try to look at a couple of things here, and these are mainly things that you will have seen before you get to calculus, but I want to get you in the habit of taking a look at stuff where I try to work some examples for you and they kind of help you out a little bit. Okay, so the first thing that we're going to look at is actually an example where we're dealing with a quadratic function, and you can do something similar for linear functions, only it'll be easier, right? So let's see if I can get this to share screen. And that is sometimes a question as to whether it will actually work out for me or not. Okay, here goes. Yay, it's going to work. All right. So the question that we're asked here is to find a quadratic function containing 3 points. And then the thing that follows from that is going to be to put it into standard form. Now, standard form has a very specific meaning, and we'll get to that here in a second. First, though, I'm going to take this that we've got on screen, which suddenly would not do anything for some reason. That's super encouraging. Okay, I'm going to take those instructions on screen. I'm going to scoot them off to the side, making them just a little bit smaller. And I am going to then start out with a function here. We'll call it f of x, because that's always a good name to call things. And we're going to say ax squared plus bx plus c. Okay, now that form for writing out the function is referred to as general form, not standard form. We'll come back to the standard form momentarily. Now, we know that we need to have those 3 points up there to be on the graph of this function. So that means that when we plug in x equals 1, we want to turn out to get the y value to be -3. So what we're going to do is to simply plug in on this. If you plug in 1 for your x's, you should have a times 1. So I'm just going to write a, and b times 1. I'm just going to write b, and plus c. And that should then turn out to be equal to -3. Okay. Similarly, if I say f of -1, since -1 squared is 1, I should still get the a, but this time I should have a minus b and then a plus c. And that should turn out to be, is it -5? Yeah. Okay. And then finally, f of 2 needs to turn out to be -5 as well. Now I'm going to show you a trick, but let's see. 2 squared is 4, so 4a, and then plus 2b and plus c equals -5. Okay. So I referred to here that, sorry folks, I've got a display that's doing something that's not quite what I want it to do. So window, move focus to the next window. Okay. Sorry, I will stop share just in case that was not doing things right there. And I will try to share again. This is a constant battle for me because the fact that I'm never entirely certain that you're getting displayed exactly what I'm seeing. All right, so we've gotten to this portion here, and this is a neat little trick that you might be able to spot here. If you look at the graph of what we're drawing, it's going to either go down like this or up like this, whichever it is. I think for this one, I worked out something where it would open downward, okay? So since we know that there are these 2 points that have the same y value for them, there's a little bit of a trick we can use. If you drew a line that had that y value there and looked at your graph, it should be symmetrical around some axis there. And that axis would be exactly halfway between those 2 x values. So that would be halfway between -1 and 2. So if you take -1 plus 2, divide by 2, just averaging them there, you get a half. So this is going to be symmetrical about x equals 1/2. And if you remember how these things go, we talk about a point HK, that's the vertex of it. And when we talk about the general form, it will work out like that, okay? So that means that we could actually skip ahead a little bit here and start writing out our f of x and use the general form because we know what the answer is going to end up to be. I'm not going to do that here, but I'm just saying that because of the way this is set up, you could skip some steps and you could actually get to the end result faster. All right. For now, though, I'm going to just do this sort of straightforwardly, okay? So the thing I'm going to observe, well, I'm trying to solve for 3 different variables with 3 equations, okay? Now, if you know how to do that with matrices, do it with matrices and just be done with it, okay? However, if what you've always done is 2 variables in everything that you've ever worked with, then you're going to try to do substitution and you're going to go round and round with it, and it's going to take a long time. So I'm going to show you doing sort of substitution here, but sort of a matrix thing. If we take these 2 equations here, all right, and we subtract them from each other. So I'm going to take a plus b plus c equals -3, and I'm going to subtract a minus b plus c equals -5. So subtracting there, I will end up with, let's see, my a's go away, my c's go away, and I end up with 2b, because I subtracted a -b, is going to be equal to, let's see, -3 minus 5. So that will end up being +2. That tells me my b is equal to 1. Okay. So once I've got that, I can substitute it back into any of these equations, and that means that I have one less thing to work with. Okay. Now the thing I'm going to do is to go ahead and take these 2 equations here, and I'm going to put the b in them, and then work with them. You don't want to substitute back into both of the 2 equations that you just worked with, because it won't get you any more information. So I'm going to have a minus 1 plus c equals -5, and 4a plus 2 plus c is equal to -5. Now, because I don't want to do any more work than I have to, I'm going to go ahead and take and add 1 to both sides on that first one. And I'm going to take and subtract 2 from both sides on that second one. And then I'm going to kind of scoot them together a little bit there. And if you prefer, you could also write that as a plus c is equal to minus 4. And 4a plus c is equal to minus 7. Okay. Now, at that point, if you have the urge to do substitution, you can certainly do substitution. I'm trying to show you this idea of eliminating variables more. We're going to take here and we're going to subtract, and you could subtract either direction there. But when we do that, we'll get minus 3a. We will get rid of our c's, and we will get, oh gosh, I'm having trouble doing that in my head. Minus 4 plus 7 is positive 3. So that means that we found out that our a has to be equal to negative 1. Okay. Now, finally, you have only one variable left, and you can plug into any of the three equations to figure this out. I'm lazy, so I will plug into the first one. The first one here, as you recall, had a plus b plus c. So I'm just going to write minus 1 plus 1 plus c equals negative 3. Those cancel. And that says your c is equal to negative 3. Okay. Now, remember all that, and I'm going to put an extra page in here, and we're going to jump over to the next page to write this down. So it's a is minus 1, b is 1, and c is minus 3. So, okay. So we've got f of x equals minus x squared plus 1x, and then was it plus 3? Dang it. Let's see. Minus 3. Okay. Now we want to put that into the standard form that has a times x minus h squared plus k, right? I'll say something about why that is in a minute, or why you want it that way in a minute. The trick is to take all the stuff with x's and factor out whatever the coefficient of x squared was. Okay. Anything that doesn't have an x in it, don't worry about it. It'll take care of itself at the end. All right. So now we need to complete the square. To complete that square, you will need to look at the coefficient of x. Since that's minus 1, then you'll take minus 1, take half of it, square it, so that gives you 1/4. Okay. So I'm going to take and substitute 1/4 in right there, not substitute, add 1/4 in. But if you had an algebra class, your teacher hopefully yelled at you anytime you just randomly added stuff into an equation. Since we added this in here, we have to also subtract it to balance out. But you have to notice that we didn't really add 1/4. We actually added minus 1/4. Okay. So we're subtracting a negative 1/4. So that means we have a negative of x minus 1/2 squared. That was just factoring, and it was designed to make sure that it would turn out that way. And then this becomes minus, oh shoot, let's see. 3 is 12/4, and so this is minus 11/4. Okay. So the reason why you might want to write it like that is because it allows us to draw our picture, our graph fairly nicely. And I should move that down a little bit. So this point on the graph, the vertex, will be 1/2. It's always the opposite sign of what you got inside there, minus 11/4. That, the part outside, is always the same sign. So if we're drawing a graph of this, your x-axis or your y-axis would end up somewhere like that. Your x-axis would be somewhere like that. And then you could put in other stuff as needed. One other thing that you might want to put in would be an axis of symmetry for this. Okay, and of course the axis of symmetry would be x equals 1/2. You might also be asked to figure out what is the y-intercept there. And of course you plug in x equals 0, and then the y value you get is -3. If you need to find x-intercepts, this one doesn't have any, but if you needed to, then you would plug in the y equal to 0 and solve for the x's. Okay, all right. So that is a quick example where we were given some points and we found a quadratic function that fit those points. Then we also took a quadratic function and put it into standard form. Those are very typical tasks to be asked to do. Then you were also asked to draw a graph of something. Now, let's say you don't have a graphing calculator because you probably do, but let's just say that you don't. Then one of the things that you're going to want to be able to do real quickly is to graph stuff online. And so here I'm going to graph minus x squared plus x minus 3. And then you can see on the graph, we have that point that I made reference to and that intercept. And if you want to go ahead and put in the x equals 1/2 line as well, then we can see all those pieces of it at once, okay? Then depending on what sort of computer system you've got, you're going to have to figure out how to take snapshots of that sort of thing. If you're on a Mac, it is Shift Command 4. If you're on a PC, depending on which version of Windows you have, surely you have Windows 10, that's pretty standard now. There is a snip tool that you can get for free. I think that's what it's called, is snip tool, that'll allow you to just take a little picture. Please, for the love of God, don't pull out your phone and take a picture of the whole damn screen, okay? At worst case, if you cannot figure out the snip tool, say something to me. But if you can't figure out the snip tool, hit Alt Print Screen, and it will make a file picture of the window that is currently active. And you can save that file and deal with it as you need to. But I will look and see what that snip tool is called and try to post something in announcements. So anyway, graphing is another thing that's pretty standard to have to do, okay? Now let's take a little shift there and think about some trigonometry stuff. In theory, that is a prerequisite for the class. It tends to be always the weak spot for most students. There's multiple reasons for that. One of them is a weird thing about how, like, if you're from North Carolina, how the high school requirements are set up. They have subtly set things up to discourage people from taking trigonometry. But in any case, we're in calculus, we need to know trigonometry. So I'm going to take a look at an equation here that asks you to use several things. And that's part of my strategy with examples I'm working for y'all is I'm going to give you examples where we do several things. I'm generally going to ask you to do examples that only do one thing. Makes it easier for me to grade. I mean, for you to figure out, yeah. All right. Anyway, so let's take a look at this example I've got going here. And all right. So the instructions say to find all the solutions to that. Now, I have used the phrasing a little bit carefully, and I'm going to resize this like before so that it's kind of out of the way. But I need you all to realize when I say find all the solutions, Often your instructions will instead say, find the solutions between 0 and 2 pi. We will find the solutions between 0 and 2 pi, and then we will think about all the ones that are outside that range by adding multiples of 2 pi. Okay, so that part will be fairly easy to do. All right, so with regard to this, I have carefully chosen an equation to bedevil you because it has both sines and cosines. If it had just cosines, this would be a little bit easier, okay? So we are going to start out with it and make that happen. So I'm going to have 4 plus cosine theta is equal to 6 times. Y'all hopefully remember that sine squared is the same as 1 minus cosine squared. Okay, don't drop that theta. And so that means that we actually have 6 minus 6 cosine squared theta over there on the right-hand side. So pulling it over to the left-hand side, we would have 6 cosine squared theta plus cosine theta, and then minus 2 after you subtract that 6 is equal to 0. Please make sure anytime that you're having to do factoring that you know to put a 0 on the right-hand side. I will be kind of a pain in your butt if you don't, because if you don't know that, then you don't know how to do the factoring end of algebra. And that's like a big first step for us, okay? So we need to factor that. Sometimes you'll run into ones where you just can't factor it, you know, but this time I designed something where you could. So what you can think about if you don't, if this is a little bit confusing to you, is you can think about, let's just treat cosine as though it was its own variable. I'll call it u, you can call it whatever you want to, all right? If I need to factor that sort of thing, then the trick that I use is I multiply the leading and trailing coefficients. So 12, I look for factors of 12, which have a difference, because that's minus, but which have a difference of 1. So the factors of 12 that have a difference of 1 are 4 and 3. The reason that I want that is I'm going to write 6u squared plus 4u minus 3u minus 2 equals 0. Okay, see how I broke it up like that? And the 4 and the 3 came in like that. And also notice that since this was a plus, then I wanted the 4 to get the positive because I wanted it to turn out to be bigger. Now, with that, you take these as pairs and see what you can factor out of them. I can take a 2u out of both in the first pair, and I'll be left with a 3u plus 2. In the second pair, I should also get the 3u plus 2, so it helps me factor the minus 1 out. If you come along and say, oh no, they didn't match, well, then you did it wrong, okay? The technique always works. Oh, wow, and for some reason the screen was slow to update. Okay, all right, and now we'll have 2u minus 1 times 3u plus 2 equals 0. Now, if you were not in need of that, you might very well have just directly gone ahead and said 2 cosine theta minus 1 times 3 cosine theta plus 2 quantity equals 0, all right? You should hopefully be in the habit of thinking of sines, cosines, and so forth as their own variables and be able to do that. So this means that cosine theta is 1/2, or cosine theta equals minus 2/3, okay? We're gonna have to solve for both of those. I am gonna start with this one because it's a special angle, and we'll come back and deal with the stuff that's not a special angle. So for this one, the first thing that you need to notice is what the reference angle is. So cosine theta equals 1/2, or if it was minus 1/2, either way, you have to think about what reference angle has a cosine being 1/2. and that's going to be pi over 3. We're not going to deal with degrees, okay? Application stuff, you may deal with degrees, but for us, we're just going to deal with radians, and then you can make the conversion as you need to, right? So we've got a reference angle of pi over 3, and we know that our angle needs to have a positive cosine. So that means that it's going to be an angle somewhere here on the right half of the circle. The x coordinates of it need to be positive, okay? So that means that either your theta is 0 plus pi over 3, or your theta is 2 pi minus pi over 3, okay? That's just the positioning stuff that if you wanted the smaller angle here, you would go from 0 up to there. If you want the larger angle, you would go most of a rotation, but you'd have to back off by that pi over 3, okay? Now I am going to tidy those up a little bit. And instead of 2 pi over 3, I will write fraction of 5 pi over 3. And then I'll take and bump this one back a little bit there. All right. Then we're going to look at our other possibility here, our cosine being negative 2 pi over 3. Okay. So for the reference angle, we're going to take an inverse cosine of 2/3. Okay. So you are undoubtedly asking, why did I not take an inverse cosine of negative 2/3? And that's because I want a reference angle. All right. So reference angles are always going to be an acute angle, and they're always going to be positive. So we're always trying to take the sine, cosine, tangent, whatever it is, and of a positive thing there to get a reference angle. So what is the inverse cosine of 2/3? I don't know. Don't have my calculator with me. Sorry. But it's a number, and that's good enough. Okay. So if you are doing this for an honest to goodness application, and you need to know the number, whip out your calculator, do as many digits as you need to. Please make sure to always use at least 3 digits past the decimal. I'm not going to be crazy about significant digits, but I get super sick of people using 2 digits for every damn thing. Okay, so we said the reference angle there, and then we have to think about our positioning on this, that we need to have a negative cosine, which means the x coordinates for the position of this angle need to be negative. That means we're in the right half of the unit circle. So we're going to say theta equals pi minus, I started to write pi over 3, but I need to say minus the inverse cosine of 2/3. And then the other one, because that one's going to be here in the second quadrant, the other one in the third quadrant we'll get from saying pi plus the inverse cosine of 2/3. Okay. Now, last piece on this is we need not just those 4 solutions. We need every solution to this equation. And it turns out that is super easy for us to be able to fix here. We just say plus 2n pi, plus 2n pi, plus 2n pi, plus 2n pi. And I should say for all the positive integers n. That z plus is just a symbol that means positive integers. The e means element of. And so what we have done here is to have written down not just 4 solutions, but infinitely many solutions. So if you needed some of those solutions, you would start plugging in n equals 1, n equals 2, n equals -17, whatever you needed. Okay, so you could get a whole bunch of them. Generally, You just need the ones for n equals 0. No extra rotations there, okay? All right, so with that example, we had an equation with trig functions in it, and you had to know one trigonometric identity. There's a lot more, but this one we only had to need to know that one. And then you had to know some special angles in order to get one of the reference angles. And you had to know about positioning to get your cosines to be positive or negative. If you get sines, instead it's vertical instead of the horizontal, okay? But in addition to the special angles, we also did something that was a non-special angle. And if you needed an approximation, use a calculator for that. I'm not gonna make you, there's no way for you to do those approximations by hand, okay? But anyway, so that's only 2 examples, but they had so many little pieces to it. I've got some problems for you all to do in class. So please come to class and I'll get you all started on those and we'll see what we can do. All right, cool. I will see you all in class.